in this question, we are given this two lines on the xy plane, and we are told that line 1 cuts the x-axis as b, which is here, okay, 0 minus 3, and has the same gradient as the line y equals to 3x minus 4. Line 2 meets line 1 at point A over here, okay, on the x-axis. So the first part A, we asked to find the equation of line 1. Okay, so we know that this line 1 has the same gradient as this line. Okay, so y equals to 3x minus 4 means this is the gradient m. So the line 1, okay, equation also m equals to 3. So the general equation can be written as y equals to 3x plus c. Okay, so to find c, we need to substitute a point, and since we know that it goes through the point b, which is 0 minus 3, we can substitute that inside. So minus 3 equals to 3, 0 plus c, so c is equals to minus 3. So the equation of line 1 is 3x, y equals to 3x minus 3. Okay, so that is part A. In part B, we asked to find the equation of line 2. So line 2, as you can see, it is a vertical line. Okay, so for a vertical line, basically you have no gradient, is undefined. So you only have x equals to some value, correct? So basically I need to find this point here, where the x value of a here, okay, because we know the y value is 0. And how do I go about doing this? Okay, so we know that since line 1 also passes through a, okay, and line 1's equation is y equals to 3x minus 3. So at a, at the point A, what do we know? We know that the value of y is equals to 0. Okay, so that means I can say that 3x minus 3 is equals to 0. So 3x equals to 3, x equals to 1. So that is basically the answer, the equation of line 2. Okay, so again, since line 2 is a vertical line, there is the gradient is not defined, so the equation is just x equals to the value here. Okay, for part C, okay, so this is part A, this is part B. Okay, and in part C, we are asked to check if the line, if the point C, which is minus 2, minus 5, does it also lie on the line as the points A and B. So A and B, as you can see, A and B are already connected here. So we have B and A. Okay, and we are asked to check whether the point C is on this line. So C is somewhere here, okay, because it is minus 2 and minus 5. Okay, so what we need to check is that this point is actually on this line. And what do we know? If C was to be on this line, so for example, if I were to extend this and say that C is here, then I can say that these 3 points A, B and C are collinear, correct? And if they are collinear means their gradient is the same. So all I need to do is to find the gradient between the 2 points and between C and one of these other points and see if they are the same. Okay, so let me write down the points again over here. So A is 1 and 0, B is 0 and minus 3, and C is minus 2 and minus 5. So what I'm going to do is first find the gradient between A and B. Okay, and that means it is minus 3 minus 0 over 0 minus 1, which is minus 3 over minus 1, which is 3. Okay, and next I'm going to find the gradient between A and C, and it's minus 5 minus 0 divided by minus 2 minus 1, which is 5 over 3. Okay, so as you can see, both of them, okay, are not the same. Okay, so MAB is not equals to MAC, which means C, okay, that means in conclusion we can say that C, okay, is not on the line joining A and B. Okay, so part C, that is the answer. So since we know that the gradient between AB and AC is not the same, okay, that concludes that C is not on the line that is currently joining A and B together. Okay, so this is another interesting question. So as you can see, as long as you understand the basics of the y equals mx plus c and the concepts of gradient and y-intercept and x-intercept, then such questions should be fairly easy to solve. Okay, so see you again in the next question. Thank you.